Hello, friends. Welcome to our channel. Let's have a look at problem 2294. This is today's daily challenge problem. So in this problem, we're going to partition a array into several subsequences, right? With some constraint. The constraint is the following. So the maximum and the minimum values in each subsequence is at most k, right? So you can see some of the examples given here. I'm not going to read through it. Here, the length of the nums can be as long as 10 to the power 5. So in other words, you cannot solve it using pure brute force. And the remaining two constraints are just a consistency constraint. So with that said, so let's look at some core ideas. So first, this problem talks about subsequence, and therefore the order is not essential. And as such, so we can do sort, right? So after we do the sort, so we can assign each element to a partition list. Let's call it P, right? So with the constraint, because it's sorted, so we just need for each such list, so the last element and the first element, the difference is bounded above by key, right? So here is an example. This is example 1. So if you sort this one, you get 1, 2, 3, 5, 6. So you can partition this into the two uh, lists. So this actually each corresponding to a subsequence. For example, 1, 2, 3 corresponding to uh, index 0, index 2, and index 3. And 5, 6 correspond to index 1 and the last index, right? Um, Here, this problem is essentially counting, right? Count the minimum number of such subsequences, right? So actually, the maximum number of such things is not meaningful because you can use each individual elements, right? So with that said, let's look at the coding. First, I'm going to just do it using the whole array, and then I'm going to use a set because essentially for this problem, unique elements are the focus. And so, for example, if you just repeat any element, for example, 6, a number of times, just regard that 6 as one single element because among those, we don't produce a gap, it's just 0, right? So here, let's do this. First, I'm going to do an in-place sort. So once we sort that, so we can initialize the partitions. So it's an empty list. Then I'm going to iterate, right? So for y in nums, then let's look at this condition. If not partitions, so the partitions are still empty. Or if it's not empty, so all partitions, the last list and the last the smallest element. So that is, let's see, if this one, so the zeroth element, let's see. Wait a minute. Let's see. So if the party y, so this is the element. So if y minus partitions, the last element, then minus this beginning one. If this is greater than k, so we need to start a new one. We're going to do partitions append. So this new one. Otherwise, so we just need to do partitions the last element, and then just append to append this back. And finally, we just need to count how many elements in this partitions. So this is the one solution. Let me first check if it works. And passes all the cases. So now let's submit for generic case. And passes all the cases. So here, let's also do some prints so that you know. print what's the partitions final state partitions. So for the first example, you will get 1, 2, 3, and 5, 6. For this one, you are going to get 1, 2, and 3. 1, 2, and 3. And for this one, k equals 0, you get a 2, 2, 4, 5. So because 2, 2 is actually the same elements, right? So you get 3. So this is the one solution. Actually, this pattern is very common. Let me add a parenthesis here. So just to make it more logically clear, right? So basically, the idea is like this. So I'm going to assign elements. So if I look at the current element, and then if we have partitions, so if I add the current element, it will yield larger gap. So I need to start a new one. Otherwise, I can append the current element to the previous partition. So that's the plain English explanation. So that's the one solution. Another one is that from example 3, you can notice that if we have if a number appears multiple times, we should group them into one list in the partition. So therefore, in practice, the repeated elements not essential, just the unique elements. So I'm going to change this one to be version 1. And then what I'm going to do is first I make it a set, right? Or you can use dictionaries just to get the unique keys. So essentially the same thing. So you can do this. So nums equals set nums. So now we get a set. And then we can do nums equals sorted nums. We get a list which contains unique elements. And then we do the same thing. So you can submit. So this is the one way. So a slightly different manipulation will be the following. So let's call this one V2. So what we can do is we can get this collections pointer nums. And then you get the just the keys nums keys. And then you do sorting, you get a list, still unique elements. Same thing essentially as here, but here I'm using a dictionary, right? So you can just submit. It also works, but this seems very fast. Yeah. So you can stick to either of those. Actually, the core logic is the same, but it's actually important to notice that we could focus on unique elements and also this line, how to explain it in plain English. So with that said, I guess that's about it for the current video. Thank you for